Hello students. So here in this video we will be discussing about Bohr's atomic model. In the previous video we have discussed Rutherford's atomic model, and there Rutherford have concluded that in an atom there is central positive charge that is considered as nucleus, and the negatively charged particle that is we have considered electron revolves around the nucleus in an orbit like the planets do. Like planets revolve around the sun, similarly the electrons also revolve around the nucleus. But there is a slight difference that in case of atom the electron revolve around the nucleus because of the Coulomb's law of force of attraction, and in the case of planets that is gravitational force of attraction. Here, since the electrons are revolving around the nucleus, they are having some particular velocity and they are constantly changing the direction. Here the direction will be somewhere like this, here the direction will be something like this, here the direction will be something like this. Because the electron is revolving with some velocity and they are having the direction, that is why we can consider that the electron is having some acceleration, that is the electron is accelerating around the nucleus. And we have studied in classical electromagnetic theory that any charged particle which is accelerating will radiate some amount of energy, and that energy is in the form of electromagnetic waves. And this electromagnetic waves that the electron is radiating is we have studied in the case of classical electromagnetic theory. And from there we can consider radiating the energy means, say in the simple word, we can consider that radiation or radiating energy means losing some amount of energy. Okay. Now, for electron revolving around a fixed particular orbit around the nucleus, electron will need some amount of energy. If it is having some high amount of energy, it will be far away or move away from the electron. If it will have less amount of energy, it will move around a closer orbit or a nearer orbit around the nucleus. So, according to the electromagnetic theory, since it is radiating the energy, it means the electron is losing some amount of energy. Since it is losing some amount of energy, it will start moving near to the nucleus, and there will be a point of time when this nucleus will try to revolve, and slowly it will collapse with the nucleus. And in this point of time when the electron will collapse or collide with the nucleus, the whole atom will be disrupted, the atom will collapse, and ultimately we can consider the universe will also collapse. But it is not happening. So since it is not happening, so there comes Bohr with his atomic model. He came with 3 postulates, and that was named as Bohr's atomic model. And what were the 3 postulates? Those are as follows. So the first postulate was, in hydrogen atom, the negatively charged particle, that is electron, revolve around the nucleus in a circular orbit. If it is revolving around the nucleus, it will have some centripetal force, of course. And since the particles in, that is the electron and the nucleus, both are charged particles, that is electron is a negatively charged particle and nucleus is a positively charged particle. So we can consider that since they are charged particles, there is some electrostatic force of attraction acting between the particles. Therefore the centripetal force is equal to the electrostatic force of attraction. So centripetal force formula, that is mv square upon r, is equal to electrostatic force of attraction, that is 1 by 4 pi epsilon naught Ze multiplied by E, where Z is any integer divided upon square of the distance between the charged particles. That is, we can consider the radius of the orbit in which that particular electron is revolving. So this was the first postulate. And in the second postulate, he described that every electron can revolve around the nucleus only in those circular orbit in which the angular momentum, that is mvr, the angular momentum is always the integral multiple of h upon 2 pi. Here n is equals to any integer, that is 1, 2, 3, 4, any integer, and h is equals to the Planck's constant, and in this multiple, in this integral multiple of h upon 2 pi, this will be equal to angular momentum of the electron, that is m into v into r, where m is the mass of the electron, v is the velocity of the electron, and r is the radius of the electron, in which radius of the orbit in which the electron is revolving. So in the third postulate, similarly in the third postulate, the Bohr concluded that the energy is radiated when an electron jumps from higher energy level to lower energy level. When it comes from higher to lower, the energy is radiated. We have just studied earlier before starting the postulates that if the energy is being radiated, it will come to the lower orbits, and when the energy is absorbed, it will move to the away, far orbits. Similarly, so an electron jumps from higher energy level to lower, it will radiate, and it will absorb when it jumps from lower energy level to higher energy level or the higher energy orbits. So the formula becomes energy in initial orbit minus energy of final orbit is equals to h into nu. So now from Bohr's all the three postulates, we will try to find the velocity of the revolving electron, the energy radiated or absorbed by the revolving electron, and the radius of the electron in which of the orbit in which the electron is revolving. So here let us consider the distance of the orbit or the electron from the nucleus. Let us consider that as small r, and the electron is revolving with the velocity, let us consider v. So from Bohr's first postulate, we have considered that centripetal force is equals to electrostatic force of attraction. Therefore centripetal force mv square upon r is equals to 1 by 4 pi epsilon naught. E is the charge on proton and E is the charge on electron. So here mv square, this r and r gets 1r and 1r gets cancelled. This r will come here, will be multiplied, which becomes mv square into r is equals to 1 by 4 pi epsilon naught. E multiplied to E is E square. Let us consider this is equation 1. And from Bohr's second postulate, we know that linear angular momentum is equals to integral multiple of h upon 2 pi. So here mv into r is equals to nh upon 2 pi. So this, let us consider this is equation 2. When we divide equation 1 from equation 2, that is mv square upon mvr is equals to 1 by 4 pi epsilon naught E multiplied by E square divided by nh upon 2 pi. So what do we get over here? This mv and mv, this r and r gets cancelled, so we are left with v only, that is 1 by 4 pi epsilon naught 2 pi e square upon nh. So we have studied that 1 by 4 pi epsilon naught is also a constant, that was k. Now from equation 2, so this is the value of the velocity of the electron revolving around the nucleus in any particular orbit with radius r. This is the velocity. Now what if we want to calculate the value of r, that is the value of radius? So from this equation we can consider nr, that is r is equals to nh upon 2 pi m multiplied by v, and we know the value of v from this equation, k 2 pi e square upon nh. So k 2 pi e square upon nh goes up in the numerator part. So here finally we get to the conclusion, n multiplied by n is n square, h multiplied by h is h square divided by 2 multiplied by 2, that is 4, for pi multiplied by pi square, this is k m e square. So this is the value of the radius of the orbit in which the electron is revolving around the nucleus. So here in this video we have got, in this derivation we have got two things, one the value of v and the other thing the value of r, that is the radius of the orbit in which the electron is revolving. Thank you very much for watching the video.